In this video, we will use row operations to solve a system of linear equations in two variables. So just a little bit of an overview before we get started with an example. Row operations can be performed on a matrix. These are things such as addition, multiplication by a constant, and interchanging rows. We'll get into specifics on which row operations are allowed in just a minute. Keep in mind that our goal when we are wanting to solve a system of linear equations is to get our matrix into row echelon form. What does row echelon form look like? Here's an example of row echelon form. We have ones down the diagonal from upper left to lower right, but on the left side of the matrix, on the left side of the line. And then there are zeros below that diagonal. Now above that diagonal there are some numbers, and that's okay. In order to get a matrix into row echelon form like this, we use row operations. So what row operations can we use to get a matrix to look like this? Well, we can interchange rows. So interchanging rows means that we can just switch rows 1 and rows 2. We can multiply a row by some constant. So we could multiply the entire row, let's say by 2 or by -1, something like that. Or sometimes this is the most useful and it is the most difficult. We can add the product of a row, so that's this one right here, multiply a row by a constant. We can take that and we can add it to another row. So we'll see that in action in just a minute. Let's try an example. Oops. Just a reminder again on our goal. So we want to get to that row echelon form by using these row operations. Now once we get there, what's the whole point of getting row echelon form? If you remember before, when we had row echelon form like this, we could write down our systems of equations that we had, and then we could work backwards, plug them in, and we could solve for the system. So that's our plan. Let's start with an example. Here we have this system of linear equations. Two equations, two variables. We want to use the Gaussian elimination process. First, we need to write the augmented matrix, because everything we do with interchanging rows, with using row operations, is going to be done with the augmented matrix. So our augmented matrix is -1, 2, -3, 4, -5, 6. Next, we're told we need to make element A1, 1, so row 1, column 1, equal to +1. How are we going to do this? How can we make this element a 1 using the row operations that we're allowed to use? We are going to multiply row 1 by -1. We can multiply that entire row by -1, and then this will become +1. So -1 times row 1, and that gives us a new matrix. What does that new matrix look like? It looks like 1, -2, +3, and then we didn't touch row 2 at all, so we're just going to copy that down. 4, -5, 6. So there is the matrix we're currently working with. Next, as we move, we want to make element 2, 1, 0. So this 4 right here needs to become 0. How are we going to do that? Well, we can't multiply or divide by anything on that row. So this is where we're going to have to use that third kind of row operation, which tells us that we can add or subtract other multiples of other rows. So we can multiply row 1 by -4 and add that to row 2. That would be -4 plus 4, and that would give us a 0. So we're going to do this by adding -4 times row 1 to row 2. So what does that look like? We're going to do -4 times row 1 plus row 2, and we get a new matrix. Now we're not actually changing row 1 at all. We are simply using the numbers in row 1 to help us manipulate row 2. So I'm going to copy down what's in row 1. I have a 1, I have a -2, and I have a 3. But those I'm not changing. Now row 2 is what I'm changing. So this element right here, 2, 1, is what I want to become 0. How do I do that? Well, let's follow what I wrote down. -4 times the corresponding element in row 1, which is 1, plus the corresponding element in row 2, which is 4. Now we'll leave that, let it be, and we'll calculate it in just a minute. Let's keep doing it for the other entries. Okay, we're following along right here. -4 times the entry in row 1 plus the entry in row 2, -5. -4 times the entry in row 1, which is 3, plus the entry in row 2, which is 6. Now we can take all of these and calculate them. And these are the new entries in row 2. So now our matrix looks like 1, -2, 3, and then -4 plus 4 is 0, +8 plus -5 is 3, -12 plus 6 is -6. So there is our new matrix. Now it's not in row echelon form yet. We have this and we have this, but we need to have our diagonal be 1s. So step 4 says to make element A22 equal to 1. So how are we going to make that's currently a 3, make it a 1? This is one where we can just multiply the entire row by a number. So we can multiply row 2 by 1/3. So 1/3 times row 2 is equal to, remember, row 1 stays the same, so I'm just going to copy it down. And then everything in row 2 gets multiplied by a 1/3. So 0, 1, -2. Now we have our row echelon form. We can write down what our systems of equations are. X minus 2y equals 3, and y equals -2. Now we can use these equations, work backwards, and solve our system. So let's plug in y equals 2 right here. And we have x minus 2 times -2 equals 3. X plus 4 equals 3. X equals -4 minus 4, -1. Great, we have one piece of our solution, but we need to know what y is. Oh hey, there it is right there. Forgot we had it. There's x, there's y. Our solution is -1, -2. I always recommend checking your solutions. So we could take these values, -1 and -2, and plug them back in for x and y in our original equations. That's solving a system using Gaussian elimination and row operations. Hope that was helpful.